This is the second mini-lecture for section 6.1 of the textbook. We're going to continue our discussion of illustrations of the fractions. The next way of illustrating fractions is fraction circles. And this again is, it's a version of the colored region model. But once again, the idea is to use the same shape to identify or to illustrate multiple fractions. Now, one thing we haven't seen yet, but that certainly is possible, is to have a numerator that is larger than the denominator. And if that's the case, you just have to have multiple units. So, for example, let's illustrate, let's say 5/3. So the thirds means we're going to divide each unit to 3 equal parts. But we're going to need 5 parts, as the numerator tells us. And a unit only has 3 parts. So we're going to need 2 units to be able to get 5 parts. So here's 1 unit, and I'll shade in all 3 parts. But we need 2 more shaded, so I'm going to add another unit. Circle of the same size. Divide it into 3 equal parts. Shade in 2 of those. And there's 5/3. Okay, in the set model, the unit is a group of objects. So if you want to illustrate A over B, you would want to start perhaps with a group of B objects. For instance, if I wanted to illustrate, let's say, 4/7, I need a group of 7 objects. I'll just draw 7 stars. And I'll just group together 4 of those, and there we go, 4 out of 7. Okay, and then last but not least, we have the number line model. Here the unit is the unit interval, for instance from 0 to 1. The fraction a over b, where b is supposed to be positive, but a could be negative or positive. It's represented by dividing each interval into b segments of equal length, and then counting the magnitude of a segments to the left or right of 0. So for example, if I want to illustrate, let's say 7/3, then I start with the number line with the integers marked out on it. This is going to have to go up to 3 perhaps. Okay, so there's the integers. And then each of these unit intervals is a unit. And so I'm going to divide each of those up into 3 equal parts, because that's what the denominator tells me I need to do. And then I count 7 of those to the right of 0. 1, 2, 3, 4, 5, 6, 7. So that tick mark right there is 7/3. Or I could illustrate it with an arrow, of course. Okay, what's nice about this model, of course, is that we can also illustrate fractions with negative numerators. So for example, suppose I want to illustrate negative 4 over 3. So now I'm just going to be counting to the left of 0. And here, well, again, the denominator is 3, so I'm going to divide each interval into 3 equal parts. It'll look something like that. And I want to count 4 segments to the left of 0. 1, 2, 3, 4. There's negative 4/3. And then here it is as an arrow. So let's talk about equivalent fractions. As you may have noticed, or as I'm sure you already know, different fractions can represent the same amount. So, for example, let's think about 2/3. We drew a picture of it a minute ago. Let's redraw that. I'll draw it kind of small. Okay, I'm going to draw it as a fraction strip. So I just take my strip, divide it into 3 equal parts, shade in 2 of them, like we just did. Okay, but now side by side with that, let's use the same fraction strip, the same rectangle. And let's illustrate 4/6 instead. Now I need to divide this into 6 equal parts, and one way to do that would be to divide it into 3 equal parts like we just did. So see, I can just kind of copy those down. See how that lines up. But then I divide each of those parts into 2 smaller parts. We have 6 total. Okay, and then I shade in 4 of those. So there's 4/6. Okay, so let's do just one more of these. So I'll use this as an example in a moment. Let's do 6/9. So once again, I start with a strip of the exact same length because I want to use the same unit so that I can compare these. And 6/9, I need to divide the strip up into 9 equal parts. And I could begin that by dividing it into 3 equal parts again. But then I divide each of those 3 parts into 3 smaller parts. So that's going to give me 9 total. Okay, and then shade in 6 of those. And of course I end up with the same shaded region. So 2/3, 4/6, 6/9 are all different fractions, but they represent the same amount. Before I talk about that, let me emphasize something here. When you draw these pictures on your own, don't draw them by drawing the little rectangles first and then adding them on. Sometimes I see students do things like that. The reason that's not good practice, and you would definitely want to avoid if you're teaching, is that you have no control over how long the strip ends up being. So never draw them like that. Okay, always start with the rectangle itself and then divide it into smaller parts. Don't stack up the parts, because you won't have any control over the length of the rectangle. And I've noticed when I give pencil and paper exams that students that draw pictures like this are the students that have a really hard time with the other basics of fractions. I think it really goes hand in hand. So practice drawing good pictures of this, and it'll help you think about them. Now, when two fractions, like 4 over 6 and 6 over 9, represent the same amount, we say that they're equivalent fractions. And we use the equal sign to express that. But right now we're not really saying that they're equal. We're saying that they are equivalent. So this word equivalent is just a way of saying that in a way they're the same, but they're not really the same. Okay, so instead of saying they're equal, we just say they're equivalent.